So your RV furnace is not working. Well, hopefully this video may save you some trouble, some time, and some money. What to do is going to be the understanding of your wires. Now, typically you're going to have 4 wires coming out of your furnace from the control board there. Anyway, you're going to have, of course, your hot wire, which will be typically a red wire. You're going to have your ground wire, which will be either typically yellow or could be a green. And then you're going to have, more than likely, 2 blue wires. Now, some older RV furnaces will only have the 1 blue wire. If you have 2 blue wires, what's happening here is the power going through the red wire and then going into the control board there is then coming back out through one of the blue wires going to your thermostat. And then when you turn on your thermostat, it's just connecting the power to the other blue wire that goes back to the control board to actually initiate the process to turn it on. Now, if you only have the 1 blue wire, that means your thermostat derives power from somewhere else, and all you have to do is put power to the 1 blue wire to get it to activate. Now that you are familiar with the wiring, let's go ahead and go through the process. So, now that we have the wiring figured out, and let's just say we went ahead and turned on our furnace, the first step of operation is going to be to turn on the blower wheel to start spinning to create flow. Once the blower wheel turns on, you're also going to have something called a sail switch. Now, sometimes they're located out here like on this one. Sometimes they're located inside the panel on here, typically right here or in the center. All its duty is to do is when the blower motor turns on, it creates air pressure pushing up on this, closing the circuit, allowing power to travel through it. Now, these can fail, and it's very typical for these to fail. If these fail, they'll fail in 2 different fashions. One, the switch will be activated, but it will not let the power through, or the switch inside gets stuck in the closed position, meaning that power will run through it all the time, regardless of this switch being activated. Now, if power runs through this switch continually, then the control board will recognize that and recognize a fail in the component systems and will keep it from turning on, or at least igniting. It'll just hear the blower turn on and eventually turn right back off. Easiest way to test this is going to be, of course, with a voltmeter. Now, you got different types of voltmeters. This one just has a ground connection and then a probe with the meter on it. Now, as you can see, I guess I have my power disconnected here. But simply just test it on the tabs there and make sure that you have no power when it's not switched on, and then the power does go through it once the switch is activated. If those are happening, you got a good switch. The next step of operation is once the power goes through that switch, it's going to go through a high temp limit switch, meaning that it's not going to let the furnace get too hot and burn itself down. And that's going to be that guy right there. Now, sometimes they're located on the back here, nice and easy and accessible. Other times they're located in between these 2 burner tubes in the back there, and it's kind of a pain in the butt to get to. Either way, for this to function correctly, you just want to have power running through it, or continuity running through it all the time. It should never be open, it should always be closed. So if you have power through there, or good continuity through there, you know that switch is good. The next step of operation, once the power goes through that switch, is to send that power back to the control board, letting you know that the cell switch is good, the temp switch is within parameters, and then the control board will send a signal to the gas valve. Your gas valve is going to be located down there, and that's going to be that guy right there. And you can see the brown and yellow wires. The yellow wires are just grounds. Now, to test your gas valves to make sure that they're operating correctly, You want to make sure that you are getting correct voltage on the brown wire. Make sure that the ground is good continuity to your ground itself. And the easy way to test that these are operating is you could either A, take them out of the assembly and put power and a ground to the valves here, and then see if you do have flow through it. Otherwise, you typically just put your finger on there and you can feel that valve opening and closing when the power is put to it. When power is given to that gas valve, the gas valve will open, allowing the gas to go through the tube and into the burn chamber. The next step is shortly after it gives power to the gas valve, is you're also going to get an ignition source from the igniter on the control board. Now, another thing you're going to want to look for is to see if your igniter is actually working correctly. Now, as you can see, most furnaces will have a little inspection window, and if you put some light in there, you'll be able to see the igniter assembly. And when it goes through the functions of trying to start, you just want to make sure that you see a spark on that igniter. Now, if you see a spark on that igniter and it still fails to light, chances are you're going to either A, have a bad sail switch or the bad thermal switch, or you're going to have a problem with the control board itself. So you'll just have to test the components individually to see if they're working properly. If you're not getting a good ignition spark, then you can remove this and inspect the igniter. The igniter, like a spark plug, will have a ceramic coating. You want to make sure that ceramic coating is not cracked, so no sparks could be let out early before it reaches the igniter tip. The igniter tips will also get extremely dirty over time in use, so you want to clean them up and make sure that it has nice, clean, shiny metal to make a really good arcing spark. Another contributing factor to the furnaces not lighting, and if your sail switch is working properly through your test, but when you turn it on it's not activating, it could just be your battery is very low. These take at least 11.5 volts to operate. Anything below that may not spin the blower wheel fast enough to actually activate the sail switch. So you'll also want to make sure your voltage values from your battery or your supply are also correct. Now, in this case, this furnace, all the components are working. It's going through all the steps, other than I'm not getting an ignition or a spark on my igniter, which is going to be telling me that the control board igniter is bad. And unfortunately, in this case, this board will have to be replaced, and we're talking a couple $100 for that, unfortunately. Now, as you can see, this furnace looks a lot different than the furnace you're probably looking at on your RV, and that's because I actually have it out of the enclosure. Let me show you what an RV in the enclosure looks like. So, minus the control board on this one being in the improper position, as you can see, this is a junk one, but you can see the housing itself that the actual furnace is located in. The one that I have on the bench over there that I'm testing is just simply out of this case. Now, depending on the type of furnace you have, to get it out of the case may vary. You'll just have to look at all the mounting screws of what holds it and contains it within that case and remove them. Thankfully, for the one that I'm working on now, it is fairly easy, as it just had one screw on the back side of it that would hold it onto the case, which sits right there, and then I was able to just slip the case right off. Well, that about does it. I gave you all the things to look at or test to make sure that you can get your furnace working, and hopefully this will save you some money.